Hi everybody, I'm Alessandro, and for this new episode of the Polimi Risk Management magazine, I flew all the way to New York to speak about a new methodology for the computation of value at risk. You may ask why New York and why exactly here in JP Morgan? Well, our story starts right here in this building some decades ago. But I don't want to talk too much, so I will leave the stage to my colleague Ellen, who has recently met two Spanish resources from Madrid, and she has something really interesting to tell us.
Hi everyone, I'm Ellen. Pascual and Ruiz, two researchers from Madrid University, have developed a new bootstrap algorithm to predict future returns and volatilities. Their idea consists of taking into account data heteroscedasticity, which means that volatilities evolve over time by simply estimating a new model at each step. We applied this procedure on returns of the Wilshire 5000 price index, modeling them as an AR1 GARC11 model as this one. Furthermore, predicted returns and volatilities look like using GARC11 Gaussian errors, and like this with errors distributed as t-student with 5 degrees of freedom. What is really important instead is the estimated density of the residuals. Both choosing Gaussian or t-student distributed errors for this model, standardized residual don't follow this distribution, mostly because of fat tails problem. Remember this last observation that could be useful later on.
Welcome back everybody. We are in Central Park now, the best place to think about our results. Using what my colleague Ellen just told us, we computed the value at risk for a delta hedged portfolio made up of a short at the money call option and a long position on the underlying index. We did it applying the full evaluation Monte Carlo approach, which involves to simulate future portfolio values in order to find a loss distribution. As you can see from this table, values obtained running the bootstrap are quite similar to the ones obtained resampling from historical returns under conditional homoscedasticity. Moreover, if we also consider values obtained from the simulation of the AR1 model, we can see how they converge at the low confidence level while they diverge at the highest confidence level. This is due to the fact of the presence of fat tails in the simulated distribution. Therefore, if we want to summarize everything, we can say that the procedure developed by Pascual and Ruiz is an effective method to compute the value at risk, since it considers heteroscedasticity and it doesn't require any assumption on the initial distribution of returns. Thanks for watching and see you at the next episode. Ciao!